Hello and welcome to 12.7 Conditional Probability. Conditional probability. In general, the probability of event E2 occurring, given that an event E1 has happened or will happen, the time relationship does not really matter, is called a conditional probability, and it's written the probability of E2 given, this vertical line means given E1. Probability of E2 given E1. Okay, so symbol, as I said, is read the probability of E2 given E1. This represents, quotation marks, represents the probability of E2 occurring, assuming that E1 has already occurred or will occur. A single card is selected from a deck of cards. Determine the probability it is a heart, given that it is red. So we're looking at the probability that it was a heart, given that it's red. Well, how many hearts are there that are red? Well, there are 13 hearts. They're all red out of the 26 red cards. There are 26 red cards altogether. So that's 1/2. I'm going to scroll this up so I can do all of example 2. So feel free to pause that. A family has 2 children, assuming that boys and girls are equally likely, 1/2 each probability. Determine the probability the family has 2 boys. So this is the probability of boy for 2 given boy in the first case. Now I think we can just call this probability of boy. It's probability of boy and boy. Probability of boy times probability of boy. 1/2 times 1/2 is 1/4. 2 boys, if you know that at least one of the children is a boy. So in this case, we're looking at probability of boy, given that 1 is a boy. So we know one of the children is a boy already. That means the second one could have been a boy or a girl, and that's going to be 1/2. For example, let me just draw a little diagram. Well, maybe I'll come back to this with C. 2 boys, given that the older child is a boy. So probability of boy, given boy was the first child born. So the first possibility that you could have had was boy, then girl. And then we could have had, from the second child born, could have been a boy or a girl. So this is boy 1, G1, B1, B2, G2. So the third case is talking about probability of 2 boys given that the older one is a boy. So boy, then boy. So we're talking about being in this situation right here. Well, probability of having 2 boys, knowing one's a boy, is 1 out of 2 possibilities. Now earlier we saw, if you want to look at these cases, we have BB, BG, GB, GG. Part B says 2 boys if you know that at least one of the children is a boy. Okay, well, probability of 2 boys, given we know that one is a boy. That's actually these 3 right here. So I probably should adjust this. Probability of boy, given that one is a boy. So our sample set, it could have been BB, BG, GB, or GG. Now if we know one's a boy, it's going to be these 3 cases. Only one of these 3 cases do we have 2 boys. One of the 3 cases where at least one of the children is a boy, do we have 2 boys. So that should be a 1 out of 3. So only one of the three possibilities, the three cases where there's a boy, Only one has 2 boys. Okay, conditional probability formula. For any 2 events, E1 and E2, probability of E1 given E2 is the number of ways E1 and E2 can occur over the number of ways E1 can occur. So n of E1 and E2 represents the number of sample points common to both events E1, event 1 and event 2, and the number of event 1 is the number of sample points in the event 1, the given event. I'm going to scroll this up, so pause if we need some more time to write this down. This can also be written symbolically as the probability of E1 given E2 is the number in E1 and E2 divided by the number of things in E1. Two dice are rolled, one after the other. Construct a sample space and determine the probability that the sum of the dots on the dice total the given. And so what I have here, this is the sample space, the entire sample space. So here we have, I don't care if you want to call this the first die, and this is the second die. And these are all the pairings. The first case says, what's the probability that the sum of the dots total 6? Okay, so we get 6 in which cases? 6 here, 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 and here out of 36. 6 times 6 is 36 possible. So the probability of 6 is 6 cases out of, I should say 5 cases out of 36. That was 1, 2, 3, 4, 5. 5 out of 36. I'm going to scroll this up so I have the whole chart on the board now for the next several problems. B says, what's the probability of a 6 if the first number is a 1? Okay, so if we know the first number is a 1, what's the probability of getting a 6? Well, there's only one case that we get a 6 knowing the first number is a 1. Equals the number of the ones that have a sum of 6 and the first number being 1 over the number of things that it's the first number being 1. There's one case in this whole row that you get a 6. These are all cases where the first number is a 1. And there are 6 cases altogether. So this is 1 over 6. How about the probability you get a sum of 6 of the first die is a 3. Probability of a 6 given, I should say sum of 6 given a 3. That's the number of the ways you can get the sum of 6 and a 3 at the same as the first number over the number of ways things you get with a 3. So here we go. First thing's a 3. Here's the one that has the sum being a 6 out of 6 options. So 1 out of 6 again. Event D says an even number. What's the probability of getting an even number if the second die is a 2? Probability of even given a 2 for the first thing. That's the number of ways you can get an even number and have the first one be a 2 over the number of ways you can have 2's. It's the first number. Okay, so here 2 is the first number. We have 1, 2, 3 evens in that row out of 6 altogether, or 1/2. I need to scroll up a little bit for the next 2. Okay, E, a number greater than 7 if the second die is a 5. I think we can still use this row. Probability of being greater than 7 given 5 for the second number. Second die. Okay? Well, here's where a die is 5. How many of these are more than 7? That's 7, so we have 1, 2, 3, 4 more than 7. That's number of the sum being greater than 7 and second die is 5. So we found that occurred 1, 2, 3, 4 times out of the number of cases where the second die is 5. That's 6, so 2/3. And the last one, what's the probability of getting a 7 or 11 if the first number is a die? Probability of 7 or 11 given first die is 5. That's the probability, or the number of ways you can get a 7 or 11, and first die is 5 over the number of ways you can have the first die be a 5. Okay, so 7 or 11. That's a 6. Here's a 7. 8, 9, 10. There's an 11. So there are 2 cases where we get a 7 or 11 divided by the first die being a 5. There are 6 cases. So 1/3. Okay, let's go on to the next page, so feel free to pause if you need to. Oh. There we go. It says use the following table, which shows the number of cars and trucks that use the Pennsylvania Turnpike on a particular day. Number of cars and trucks that used and did not use Easy Pass on the same day is also recorded. It's Easy Pass, a little electronic thing that goes in your windshield, and they read it and they charge your credit card or your account. Okay, so we have Easy Pass, used and not used, total, cars, trucks, and the total number of vehicles. If one of these vehicles is selected at random, determine the probability as a decimal number, rounded to 4 decimal places, that the vehicle was a car. So the probability of a car, well, how many cars were there? 1,462 out of 2,461 altogether. And that's going to be 0.5941. What's the probability of the vehicle used Easy Pass? So probability of Easy Pass. We have 843 over our total of 2,461. And that's going to be 0.3425. It's a little more than a third of the people used Easy Pass. So C says, what's the probability that the vehicle used Easy Pass given that the vehicle was a car? So here we have probability of Easy Pass given that it's a car. So that's going to be the probability of being an Easy Pass user and a car divided by, not probability, the number of, divided by the number of cars. There are 527 cars that use Easy Pass. Out of how many cars? 1,462. That's 0.3605. So the probability of being a car that used Easy Pass is greater than the probability of just using Easy Pass in general. It means trucks must have a lower usage rate. Okay, I want you to write that down. I'm going to have to scroll to get to D, E, and F. Okay, what D? The vehicle used easy pass given the vehicle was a truck. So probability of easy pass given that's a truck. That's the probability of easy pass and being a truck. I keep saying probability. I need to go back to the number of divided by the number of trucks. So if we look at that, oops, we have trucks 316 using easy pass out of 999. And that would be 0.3163. So they do have a lower rate of usage. Now, what's the probability the vehicle was a car given that it used easy pass? It's probability, it's the number of cars and easy pass. This time, though, divided by the number of easy pass users. So number of cars, we had 527 using easy pass, but the number of easy pass users was 843 there. It's 0.6251. And the last one from this example and this section, the probability that the vehicle was a truck given that the vehicle used easy pass. So probability of truck given easy pass. That's going to be the number of trucks and easy pass divided by the number for easy pass. Well, part D gave us the number of trucks and easy pass was 316. And part E gave us the number of easy pass is 843. And we have 0.3749. Or we could have just subtracted this from 1. Okay. And that'll do it for section 12.6. Oh, sorry, 12.7, conditional probability. Thank you. Send me your questions.